Good morning again, everyone. Today we are going to present you about the water treatment project and how we learn from this project. At the beginning of the semester, we study about the environmental and energy issue in the world right now, and the topic that we were interested in the most, it was wastewater, because we think that wastewater is everywhere. Anyone can produce wastewater. That's why we were very interested in this topic. After we know what we're interested in, we start to track it down. We find the pathway of the wastewater and find how it becomes wastewater. We find out that the water begins at the forest and then gather up to be a stream and river and then flow to the city, to the community for the human to use. And after human use them, the water become contaminated and then become wastewater. And the process of becoming wastewater is the process which will disturb the equilibrium. When the equilibrium is not being disturbed, it means that everything involved gets the benefit. For example, the water that just came out from the forest, it is clean, right? Fish can swim in it, some living things can stay in it, and also human can use it. But that's equilibrium, meaning everything get the benefit. Fish can swim, human can use it, bacteria can live in it. But when it gets contaminated by the using from human, for example, like when it gets some organic compounds in it, bacteria will get the most benefit. Those living things will be happy because they have lots of food to digest and to reproduce. But however, fish cannot swim in it, human cannot use the water. That's when the equilibrium is disturbed. So after we know the pathway of the water and how it becomes an issue, we went to see the real thing. Oops. We went to Mae Khan at Chiang Mai to see the forest, the beginning of the water. We examined the water by using by observing the animals in the water, which will tell us how good water is. For example, like some animal which is really sensitive need a really good water to live in it. And if we found them, we can say that the water is clean. And this is the example of the mayflies that we found in the water, meaning the water at the beginning at the forest is clean. Then we look at the wastewater. So after we looked at the beginning of the pathway, we come back and look at the utilizer, or us, or every human beings. We all produce wastewater commonly in our daily life. So, but with this school, where there are a lot of people, it's a big community, so the amount of wastewater being produced each day is quite a lot. So this school is having a lot of impact to the nature. And 8 years ago, we realized this point. So our teachers and the former students who studied for us realized this and put up with water treatment project. So the water treatment project began and improved itself for 8 years, and here it comes to us. We study on the problem-based learning, which there are 3 main steps of learning. The first one is problem assign, where we get the problem, and the next one is thinking, what we need to know, what information we are going to do the research on. And the third one is to learn and apply those knowledge to solve the problem. So before we could get the problem to ourselves, we
school, around the school, we going out and like measuring how bad the water around the school is. We examine the water, and finally we came up with this problem. The problem is the Patarapa buildings or the lower secondary schools building system, water treatment system is not clean and it's inefficient. Like the water that coming out of it is not quite good. You can see a lot of particles, small particles in it. So that's our main goal, to improve and make this system better. So come to the next step, the step of identifying what we need to know. So we have three main group of knowledge we need to know. So the first one is how wastewater occur. The second one is how to measure the quality of water. The last one is ways or like possible ways to purify the water. And these three groups of knowledge, we have to know some like little knowledge that we can get in the classroom. Like for the first one, we need to know basics about organic compound, decomposition of bacteria, and some redox reaction. And the second one is how to measure the water quality. We need to know, we came up with four main ways of treating the water. The first one is dissolved oxygen, or DO. The second one is COD, or chemical oxygen demand. The next one is biochemical oxygen demand, and the last one is pH. So in order to understand this process of measuring how bad the water is, or the water quality, we need to know like how the concentration of solutions work, how stoichiometry work, and acid-base, and some process of titration. And the last one is possible ways to purify water. We need to know, like we came up with three main ways. The first way is biological way. The second one is chemical way, and the last one is physical way. So for biological way, we need to understand how cell respiration work for both aerobic and anaerobic bacteria. The chemical way, we need to understand the chemical reaction, and the physical way, we need to understand how the liquid separate. Like we need to understand the density of it and the polarity of it.
Okay, first one, the dissolved oxygen. We have to understand the chemical reaction of it. I'm gonna tell you how it works. Okay, so start with the manganese hydroxide will react with oxygen within the water, because dissolved oxygen is the method to find how many oxygen we have in the water. So this substance will react with oxygen and become manganite, right? Manganite. And then this manganite will react with the sulfuric acid in the soluble, and then become the manganese sulfate. And this manganese sulfate will react with the sodium iodide to become iodine. So overall, it's like oxygen react with some substances and finally become iodine. The amount of iodine occur will proportional to the amount of oxygen that is in the water. And then we finally found the amount of iodine by titrated with the sodium thiosulfate. And when we know the amount of iodine, like I said before, we will be able to know the amount of oxygen that dissolved in the water. That is me doing the experiment. That was the titration process. Next, the chemical oxygen demand, or COD. Chemical oxygen demand will let us know how many chemical compounds do we have in the water. So this is the representative of the the organic compound in the water, we will react it with the potassium dichromate and it will become something else. Then we find the amount of potassium dichromate left. Like some potassium dichromate have to oxidize the organic compound, and then we find how much potassium dichromate we have left by titrating it with the ferro indicator to find how much we have left, and by comparing it to the distilled water, to the pure water. Is there any question? I mean, I might not order it correctly, but yes. Okay, so organic compound is oxidized by potassium dichromate, and then we measure the potassium dichromate left. Okay, and that will tell us how much organic compound we have in the water, in our sample. That is me, also doing the chemical oxygen demand. Sure.
How often do you test the water?
We test it every time we do something new. Like when we, okay, at first we have to do it because we need to know how bad the water is. That's the first time, and then we try to fix things, and then we test it again to see if the water improves.
So after we know how to measure how the quality of the water is, we come to the next step, is the possible way to purify water. So we're going to focus on how to get the organic compound out of water, because the wastewater from our school is basically from cooking, for washing dishes, and from food. So there's no heavy metal or some toxic chemical. So we're gonna focus on biological way to treat the water. So the main concept of treating the water is to accelerate the process of the nature. So like what you need to understand first is the nature have its own way to treat the water. Like if you left a glass of contaminated water alone, it will be clean someday. So but this process is kind of too slow for us. Like we can't wait forever to let the nature clean up our large amount of wastewater. So we have to accelerate it. So as I said before, we focus on biological way because it's suitable for our wastewater, like contaminated from food and organic compound. And what the other reason why we focus on organic way is it is able to take care of itself. It doesn't need to be added by potential dangerous like chemical. Like it can sustain, it is sustainable, it can like clean itself up normally. So we came up with 4 main possible ways to clean water. So the first one is aerated lagoon. It is basically a tank that added oxygen all the time. It is kind of expensive because we need to add power into oxygen pump all the time, so that might not work very well. The next one is stabilization pond. It is basically just a tank leaving the water alone for a long time. So it requires a large area and large area to store the water and let them clean itself. The next one is constructed with land. It is like a mock-up. It is a human-made environment like human-made nature. It is a place where there's grass, there's soils, rocks, sands, all natural stuff that can clean up water. And the last one is activated sludge. This one is kind of like aerated lagoon where there is an oxygen adding part at the beginning, and the next part will be precipitation where the sludge will sink down to the bottom and leaving the clean water up on top. So after we research on possible ways, we did some research in what we already have in our school. So what we already have in our school is the water treatment system that is modified from activated sludge. So my friends will explain about this.
So, hello everyone. So I would like to guide you to each section of our system. So, according to this picture, there are three main parts of the system. The first part is the grease trap, which is the first place that the water enters the system. So, in this section, as my friend have already said, the main substance in the wastewater from our school is the lipid. And in this part of the tank, the lipid will be roughly eliminated. So, let me explain to you about the disadvantage point and the advantage point of lipid. So, first of all, lipids by itself, it has a bigger and longer molecules formula than other substances in wastewater. So, it is difficult for bacteria to digest it, and similarly, the bacteria will take a long time to digest them. However, the advantage point of lipid is that right here. So, it is acknowledged that if we like mix lipid and water together and leave it for a moment, the lipid will slowly flow to the surface. And why this happened? Because the lipid by itself, it is non-polarity substance, and its density is less than water. For this reason, it can be separated. So after the lipids separate to the surface of the water, it is our duty, every student's duties, to scoop it up from the water, so we can decrease the amount of waste from the water. So the next section is oxygen addition section. This section located next to the grease trap. So as I have already stated, our system uses bacteria to digest the waste. So let me quickly explain to you about types of bacteria that we found in our system. So basically, we have two types of bacteria. The first one is anaerobic bacteria. This kind of bacteria, it doesn't require oxygen to work. However, the second one is the aerobic bacteria, which is this one right here. This one is kind of oxygen required bacteria. So what is the difference? The first difference is that the anaerobic bacteria, or the non-oxygen required bacteria, it will produce this substance, this compound, hydrogen sulfide, and this compound by itself, it produces unpleasant smell, which is not good for us. On the other hand, the aerobic bacteria, which is oxygen required bacteria, it doesn't produce any unpleasant smell at all. So, actually, according to this diagram right here, you can see that the aerobic bacteria is more efficient according to this line. I mean, it can digest more and more waste at the same time. However, the anaerobic bacteria is not so efficient comparing to the aerobic. So, yeah, also the anaerobic bacteria also produce the unpleasant smell. So, yeah, when water passes to this section of the system, all the waste, all the organic substance will be digested by bacteria in these 6 tanks right here. After that, the wastewater will pass to the final section of the system, which is precipitation part. In this part, all the bacteria mass will sink to the bottom. So why do they sink to the bottom? Well, imagine the people when they eat a lot, they drink a lot, they will get fatter and fatter, and these people cannot swim, for example, and they will slowly sink to the bottom like bacteria. So bacteria is the same thing. It digests a lot of waste from here and here. So in this tank, we just leave it for a moment and wait for them to sink to the bottom of the tank. So after all the bacteria sink to the bottom of the tank, we have purified water on the surface. So this purified water will be distributed to public, and that's how it's working.
Question?
Yep.
What do you do with the precipitate? After a while it builds up, both the sludge and the bacteria. How do you get that out?
So in this participation tank, after all the microbes fall to the bottom of the tank, we have kind of we have a small path to flush it out from the bottom of the tank. So next, my friends, we're going to continue our work.
So that was how the old system worked. But still, my friend said at the beginning that the old system didn't work well. So we have to do some experiment to find why didn't it work well. The first experiment, we measured the chemical oxygen demand, the organic compound in the water, and we found that the amount of the organic compound in the table is higher than it should be. Then we know that we have a problem. Next, we do the dissolved oxygen experiment to find if oxygen is adequate for the bacteria. For this part, if the oxygen adding is adequate for the bacteria to digest the organic compound. And what we find is in this graph, you can see that this is time versus the amount of dissolved oxygen. You can see that in the morning the dissolved oxygen is really high, but suddenly at around noon, after the lunch, after the cooking, the dissolved oxygen start to drop to 0 at 2 to 4 p.m. right there. It means that in that time, even though this portion still adding some oxygen into it, the bacteria is still using the oxygen, meaning that there are still lots of organic compound in it. Meaning that at this time, the organic compound is still in the water. And we measure the dissolved oxygen from this tank. So this is the last tank before the precipitation portion, meaning that at this time, there's still lots of organic compound in it. And when the water the new water push the old water, there's still some organic compound. And that's not good because there are some organic compound left at the last step. So we wonder why didn't all these 5 tanks help eliminate the organic compound? So we did the next experiment to measure the quantity of used water per day.
we thought that why the water wasn't clean enough was because of the water quantity come into this system each day is too much for it to handle. So we measured it and came up with this result. So the water that come into this system each day is about 2,500 liters or 2.5 cubic meters. But as you can see, like this part can only have 1.8 cubic meters, and the water should be in there for a day, like to let the grease go up. So that's not enough at all. And also this precipitation part, the water should be left in there for a day too. So this part is not big enough for the water coming into the system each day. So, but what you need to know first is this system was built like 3 years ago when the building has less students than in the present. So after the number of students increase, like the amount of water increase and affecting this system. So we go on to the next step. We design a new system to improve. To improve. So as I said, these two portions have problem, right? So we are gonna rebuild these two portions. So the factor that we thought about is the capacity. Like it should be like 2 times of the amount of water coming into it each day, because like it is like a safety factor for it to stay in there for a day. Like we need it to stay in there for a day. So we add some more capacity to it. And another concern factor is the limited area, because where this system is, it is only small area. So we can't really push it, we can't build it a bigger one. We can only use the area that we only have. And the third one is the height. We have one system that the height is about this high, and it is not good at all because people who walk past it get a bad smell, and we got a lot of concern from it. And the last one is it is easy to maintain and understand, because we are not the only one who do it. The next generation will continue, and it should be like the simplest one. So we make it easy to understand for the next group of people who will continue doing this project. So we came up with this plan. This one is for the grease trap. This one is, the bottom one is top view of it. This one is a cross-section view. So it's gonna look something like this.
So, after we have finished our outline, the outline for our system, we represent our outline to teachers and construction teams. So, this is me. This is me. This is me. Yeah. So, we present our framework to the construction teams and teachers and ask them for permission for financial support. Alright, so after we get some financial support from teacher and school, we start the process. We start the construction process. In fact, we already have the construction teams to build up the tank, but 4 of us is kind of their assistants. So yeah, we work like 25% of the whole project. The construction project. Yeah.
So after the construction, we did some following up. We see how good or how the water is going. So the treated water does not look good at all after we built a new one. There are a lot of noticeable particles in it. So, and we also noticed that the bubble from dishwashing liquid is floating in this 4 section, which is not good because it indicates that maybe the water, the balance of water from this side and this side is uneven. That means all the water does not go into the oxygen portion equally. So that is wrong. So we came up with this experiment to identify if this series of tank and this series of tank get the same amount of water. The result is no, it is about 1.5 times more. This side gets more water than this side. The red one gets more than the yellow one. So what we did after that is we replacing pipe. Like as you can see before, like after the grease trap, it separates into 2 sections of oxygen adding tanks. And after we did some renovation, we put it like this. So every liter of water we go through every part of the portion. So that is, so we're gonna use the system efficiently. So.
How does the water go through each container? Is it gravity fed or do you have a pump?
It's a gravity like
So,
this.
So they start out higher and go down.
Yes. And so the latest COD data, because this project is not done yet, so we did some COD after like a week before today. So this one is what we are working on, the Patarapa building. So the COD in is about 1,300 and out is 150, which is quite still not clean enough because the clean one should be around 120 milligrams per liter. And as you can see, the other 2 still have some problems too. So it's over to 120 milligrams per liter.
So that was all how we solved the end of the problem. But that's not good because we also have to solve the cause of the problem too, because as you see, the students use water and then water get wasted and then we have to treat the water. If we only treat the water, that's not good enough because the student can cause more and more and more problem, and that's infinite. So we have to solve at the user of the water too. So we publicize and educating all the students at the building about the consequences of from their behavior and tour them around to see the system, the water treatment system, to get them involved. And also we also point out the consequences of the dishwashing liquid, because this dishwashing liquid is also an organic compound. When it goes into the system, it will make bacteria work harder, of course. And also the dishwashing liquid is also an emulsifier, which will mix water and grease together. That will make us not able to scoop the grease out and put it out. So we educate them about how bad this dishwashing liquid is, and tell them. And that is me telling them, educating them about the consequences from their behavior. And after we solve the problem, we have a plan for future. even though the water is not purified enough, we also think ahead and plan something. After the water is clean, we were thinking about using it to water the plants around the school, so we can reuse the water and we don't have to get more water just to water the plants. And we also planned on use the clean water to wash the recyclable trash, like the milk box, the plastic bag that is dirty. We can use this water to clean it before, and we can recycle it. And also, this is the conclusion of what we have learned from doing this project. Skill, knowledge, and then change in ourselves.
So for skills, we definitely learn something about teamwork because we are a group. So we have to work on that a lot. And some critical thinking and analyzing of how the result of one experiment can be another problem to the next experiment. And we learn how to use tools like lab tools, chemistry tools, and we have some like researching about what we don't know to know it. And the knowledge is basically about measuring the water quality, the chemical reaction, chemistry, and water treatment, like cell respiration and physical properties of water. And we did some math, like calculating volume, some like easy math. And we did get some construction knowledge from our building, from our construction. Like we got to be their helper, so we know the process better, know how to do the cement and concrete. And the last one is the most important thing, is the change in ourselves. For me, after doing this project, I have a more attitude on what is coming if I'm doing something. For example, what if I'm gonna turn on the air conditioner? It's gonna use up a lot of energy and it's gonna cost something. Something bad is gonna happen if I do it. So it's like giving me that point of view.
So that's the end of our presentation. Thank you for listening.